Hello, let's continue our Sudoku adventure with At the End of My Rope by Matt Tressel. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. The way these work is they are, the cage is the dotted lines that surround cells, and the value in the top left tells you the sum. So these two sum to 6, these two sum to 8, these two sum to 6, and these two sum to 8. We also have Ren band lines in here. The way these work is they have a set of consecutive non-repeating digits in any order. So think about a set of consecutive digits, like four, in this case, 4 of them. So 2, 3, 4, 5, right? I could do 2, 3, 4, 5. That's allowed, but it doesn't actually care about the order. So I could do 3, 5, 2, 4. That would work as well. All that matters is that when you look at all the digits that end up on the Ren band, they end up being a non-repeating consecutive set of digits. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. I'm looking to see if there's any geometric arguments we can make here. Like what I'm looking at is, for example, here, let's call whatever this digit is green. We don't know what it is, but we can call it green. And so where does green go in this box? Because it looks up here, can't share a column. There's only one green in every column box, so nothing here. And we also can't repeat on a Ren band, so there's no greens here. So green ends up in one of these two. That points up here along with that, putting a green in one of these two. Now we can call this purple. We know it's distinct from green because it's on the same Ren band. And so the purple ends up in one of these two by similar logic, and then in one of these two. I'm also seeing the same thing over here. Now we know that this isn't green, but we don't know that it's not purple. It could be purple. So we got to be a little careful. But the geometry isn't all that exciting. It goes here and here, and then this one goes here and here. So there must be more going on here. To add to 6, these both add to 6. There's only two ways, 1, 5 and 2, 4. I'm not really seeing what to do with that. 8, the ways to add to 8. We can't do 1, 7 because there's no 7. So we can do 2, 6 or 3, 5. All right, so there is logic with 4-cell Ren bands that can be interesting, which is they use up quite a bit of our range. So just using these 3 as scratch, I'm not actually penciling these cells. These are the possible sequences. 1, 2, 3, 4, oops, 1, 2, 3, 4, 2, 3, 4, 5, or 3, 4, 5, 6. That's it. So one way to think about this is what are the 2 digits that are missing? This is missing the 5, 6, this is missing the 1, 6, and this is missing the 1, 2. So we're only missing 2 digits. All other digits must be in there. And notice we can only be missing 1s, 2s, 5s, and 6s, meaning the 3 and the 4 have to be on this line and this line. They contain a 3 and a 4. The 4 is not in the 8 cages, so the 4 has to be in one of these two. And because it's not in the 8 cage, it's here and it's here. Now, this has to have a 3, and so the 3 goes here and here and here. Okay. So now we know purple and green are not 4, which we kind of already knew. They're also not 1. What else can I do here? We do have this little Ren band I haven't looked at. Is there geometry here that might be interesting? Not that I'm really seeing. Okay, so what am I missing then? Do I need to color these? The problem is I don't know if the problem with coloring it is I don't know if it's purple or not. I don't know if this is green. 1, 5. Yeah, I don't know. We're missing 1, 2, 1, 6, or 5, 6. That's it. I can't say anything like these two add to 8 and are different. Therefore, like one's 5, one's 6, because we could even use the same sum as far as I can tell. Like we could do a 2, 6 here and 2, 6 here, and these would just be, one would be 2 and one would be 6. Actually, that doesn't work. Okay. Okay, look what happens if we try to make these the same sum as each other. That makes these two have to also be 2, 6. And that doesn't work for the Renban because it would be repeating both the 2 and the 6 on the Renban. So the result is that one of these is 2, 6 and one of these is 3, 5. So how do we... So whatever this digit is, then... Hold on. I'm trying to think about this. So we can color this orange and this blue because we know that they are different than green and purple. This can't be green, obviously, and it can't be purple because we know that purple is a different way to add to 8. So blue... So we know that orange joins the purple here. This is a purple-orange pair. Oh, so I think we're vertically roped. Because this is orange-purple, this is orange-purple, and this is orange-purple. Yes. And so then this is blue-green. This is blue-green. And then whatever's here, we'll call red-yellow, red-yellow, red-yellow. So that we're vertically roped. And then this is also going to be vertically roped. But we don't quite know how to transfer the colors yet. But I wonder if there's more we can do with that. So red-yellow involves 4. What else? So we know these are 2, 3, 5, 6. These are 2, 3, 5, 6. So this has to be the 1, 4 that's missing. And so now we know there's a 1 on the Renban. So it's going to be 1, 2, 3, 4 because there is a 1. And so as a result, they can't have 5, 6 on it. So this is a 2, 3 pair. And then these are the 5, 6. Okay. 2, 3, 5, 6. So we have similar logic here, and I wonder if this Renban is important now. So I'm not sure if there's anything else we can do here. This is a 2, 3 pair, but I don't know what we can do with that. What else can we do? I think we're going to have to look at the roping over here. How does it rope? So this goes here and here. Let's just call that gray for a second. And then this has to go here and here. So we'll just call that darker gray. All right, so this is how this is roped. So yeah, these are the 2 digits missing from 1, 2, 4, 5 then, right? Yeah, they are. So these are the 3, 6. And so that puts a 6 on this Renban, meaning it can't have 1 or 2 on it. So this is 4, 5, and this is 1, 2. So what does that mean for me? So that means that all of these sort of darker grays are 1, 2, 4, 5, and so are these. Okay, 1, 2, 4, 5 here. Now, how do we reconcile this? There doesn't seem to be too much to reconcile here. All right, so is it not the Renban then? All right, I'm wondering if the colors are overkill at this point. Maybe I'll just represent the roping over here in the same subtle way. So here's how this is roped. This one's roped this way. And then we'll leave the other one white. Okay. So this is going to be a way to add to 6. Okay, so it's not just any digits. This adds to 6. So it's either going to be 1, 5 or 2, 4. 1, 5 is too far away. Okay. This is a 3-cell Renban. 1 and 5, you can't fill the gap of 2, 3, 4 with 1 cell. So this can't be 1, 5. It must be 2, 4, which forces this to be a 3. And I think that's going to do it. This is not a 3. It's not 3, 6. So that's the 2. 2 plus 6 is 8. This is going to be 3 plus 5 is 8. So this is 2, 6. This is a 2-6. This is a 3-5. This is a 5. Okay. Over here we get 3 and 6. We get the 5 and 3. All right, cleaning all this up. We get the 4 and the 2. That's the 1 and the 5. We get the 6 and 3. That's 1 and 5. 2 and 6. 4 and 1. 2 and 4. 2 and 4. We get the 1 and 5. 1 and 4. 4 and 1. And we're done. All right. Just had to, yeah, this was definitely key to resolve everything. I had to recognize that this wasn't just 1, 2, 4, 5. This was 2 digits that had to 6, which completely excluded 1, 5 from there. So we had to recognize that this pattern caused that roping behavior first. Very cool. All right. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.